Thank you and hello everyone. Vaccination as a concept was introduced by the British physician Edward Jenner in the late 18th century against the smallpox virus. And since then, it is considered to be one of the most significant advancements in medical history, both in saving millions of lives and billions of dollars in healthcare costs. However, most vaccinations are carried out through needle-based syringes. And they are associated with needle phobia, needle aversion, accidental needle stick injuries, and more importantly, on the mechanistic side, they are limited in their efficacy against viral infections and cancer. Now, this is because if we look at the skin anatomy or skin structure, the immune cells to be targeted are located just below the top layer of the skin, whereas a needle goes all the way below into the blood capillaries, thereby limiting its efficacy. Now, the attractive alternative to this needle-based immunization approach would be simply skin vaccination. However, here, then the challenge is the topmost layer, which is organized in a brick and mortar structure with the dead skin cells, corneocytes embedded in the lipid bilayer mortar. In my work, I address this challenge using low-frequency ultrasound, also known as low-frequency sonophoresis on the skin. It's basically a longitudinal pressure wave that is characterized by an amplitude and frequency. Compared to the use of high-frequency ultrasound in megahertz region that is usually used in gynecology diagnostics, we use low-frequency ultrasound around the 20 kilohertz area to safely and reversibly open the skin to allow the transdermal topical antigen to permeate into the skin immune cells. Now, this happens because when we apply low-frequency ultrasound through a liquid medium, we induce both stable cavitation events and transient cavitation events, which increase in size depending going on through the pressure cycles and eventually impinge on the skin surface as microgens. This can also be thought of as hammers hammering into the top layer of the skin, thereby allowing our topical antigen to reach the skin immune cells. In this diagram, we can see that through only a 30 seconds low-frequency ultrasound treatment on the skin, we are able to highly disperse our red-labeled vaccine into the skin where the immune cells are labeled in the green color, compared to very localized region in an untreated sample. Now, coming back to what exactly constitutes an immune response. Once we reach our target immune cells, what happens is we can go either two routes. One way is where we are actually activating B cells or antibodies, which are generally associated with immunity. However, antibodies are only good for neutralizing infections outside the cell. Whereas when you have a virally infected cell or a disease cell like cancer, you need these cancer cytotoxic T cells. And it turns out that when targeting these skin immune cells are efficient at activating these cytotoxic killer T cells. Now, coming back to our ultrasound skin treatment, with a 30-second treatment through the aqueous medium, we not only open up the skin to these skin immune cells, but we also make them more efficient in taking this antigen and activating the downstream killer T cells. However, when you do needle-based administration, because of the longer indirect muscular route, you end up generating only B cells. Considering this in an in vivo model, what we did is we took a healthy cohort of mice and challenged them with a tumor cell line, and after developing a well-established tumor growth, we started our ultrasound immunization protocol. Compared to the controls, where most of the tumors grew uninhibited and all the mice succumbed eventually, our ultrasound treatment, on the other hand, not only regressively slowed down the tumor growth, but also enhanced survival. Additionally, on looking or analyzing the circulatory blood, we found a significantly higher growth of circulating killer T cells, thereby confirming our hypothesis in these killer T cells playing an active role in reducing the tumor growth. In conclusion, This ultrasound, low-frequency ultrasound platform is a safe and reversible method to target the immune cells and also activate the killer T cells downstream. Future work definitely includes using this technology for forever evolving viral strains and cancer. Thank you.